Welcome to Section 3 on Conditionals and Control Flow. In this section, we'll learn how programs make decisions and how we can write code that reacts dynamically to different inputs and situations. By the end of this section, you'll understand how decision-making works in Python, how to write if, else if, and else statements, how to combine conditions using logical operators, and how to debug common errors. Every decision starts with a simple question that has a true or false answer. For example, is it raining? If yes, you take an umbrella. If no, you don't. Programs follow this exact same logic using conditional statements. Conditionals are important because they allow programs to react to data, handle different types of inputs, and create dynamic behavior instead of always producing the same output. We can think of conditionals as translating flowcharts into code. A decision point in a flowchart becomes an if statement in Python. And each possible path becomes a block of code. What is a condition? A condition is any expression that evaluates to either true or false. This result determines which path the program will take. So for example, in this case, is 5 greater than 3? It's true. Is 2 equals 4? It's false. So the result will determine what the program will do. Boolean values are simply true and false. These are the only two possible outcomes of any condition, and they form the foundation of all decision-making and programming. So the same way, is 5 greater than 3? It's true. If is 5 equals 1? It's false. Comparison operators allow us to create conditions. For example, we can check if two values are equal using double equals or compare values using greater than, less than, or similar operators. So for this one, you are checking is x equals 10. So before you have assigned x equals 10. So when you're just checking is it equals to 10, it is true. Is x greater than y? So before it was assigned, x was assigned number 10 and y was assigned number 5. So 10 is greater than 5. Is y not equals to 5? However, y is 5. So 5 is equals 5. So 5, it will turn false because y is 5. In this example, we check whether x is greater than 5 and whether x is equals to 3. So first, you were assigning 10 to x. And then you're seeing if x is greater than 5. So the print will be true. Now, is x equal to 3? So 10 is not equals to 3. So the result will be false. So the first condition is true and the false for the second condition. It is all about checking what it has been assigned to. The output confirms this. Since 10 is greater than 5, the result is true. Since 10 is not equals to 3, the result is false. So I'm just showing you the outputs here. An if statement allows us to execute code only when a condition is true. If the condition is false, the program simply skips that block. In this example, we check if the age is greater than or equals to 18. The correct condition is age the greater than equals 18. So if your age is 18 or above, you can vote. So since the age had been assigned 18, so the age is currently equals to 18. So the print function will give us you can vote, since the condition is true. Here it's showing the output. It's showing that the condition was met, so the code inside the if block was executed. There are three key parts to an if statement. The condition, which must be true or false, the colon, which starts the block, and the indentation, which defines the code that belongs to the condition. Indentation is very important in Python. It defines the structure of the program. If indentation is incorrect, the program will not run. So be very careful of putting indentation. So when you're inside the condition of if, make sure you give the appropriate space. So there is the 4-space rule. So the official Python style guide PEP8 recommends using 4 spaces per indentation level. So do not make tabs and spaces. An if-else statement produces two possible paths. If the condition is true, one block runs. If it's false, the other block runs. Only one path is ever executed. So once it checks the condition, if it's true, it does A. If it's false, it does B. In this example, age is assigned the number 15. The condition age is greater than equals 18 would be false. So the program skips the if block and executes the else block, and it would print minor. So showing the output here, it confirms this. Since the condition is false, because 15 is not greater than or equals 18, the else block is executed. Conditionals are used in many real-world systems, such as login validation, access control, game logic, and device automation. So you can see for the login validation, it checks if password is equals to the safe password. It calls a function, else it shows the error of wrong password. Similarly, the if-else statements are there for the access control and the game logic. In this exercise, we check whether a number is even or odd. So in section 2, we went through this. The correct condition would be number modulo operator 2 with 2 equals 0. right? It's just there in the hint. So if this is true, the number is even. Otherwise, it is odd. For the example number 42, the correct output is even. And the energy example, if energy underscore kWh is 650, since it's greater than 500, the output is high usage. It's just showing a real world context. When we have more than two possible outcomes, we use if, else if, and else. Python checks conditions from top to bottom and stops at the first true condition. In this example, the correct conditions are score greater than or equals 80 and score greater than equals 60. So the score is assigned a value 75. So let's start. So if score is greater than or equals 80, print A. Since it's not 75 is not greater than or equals 80, we cannot print A. So we move to the second else if part. So else if score is greater than or equals to 60. Since 75 is greater than or equals 60, it would print B. Just showing the output. The output is confirming the logic. Python checks each condition in order and executes the first one that is true. Order matters in if-elif-else structures. Python stops at the first true condition. So more specific conditions must always come first. So for example, in this one, if we are going to be checking if score is greater than or equals 90, it would be the first check. Then we'll have the second check of 80, and then others would be skipped. Always check the most specific or highest threshold conditions first to avoid logic errors like unreachable code. This structure is used in real-world scenarios such as grading systems, weather classification, and as well as energy usage categorization. You can see in the academic grading, it's the normal one of if score is greater than or equals 90, then this score is printed or a stat score, and then the else, right? And for the weather, if temperature is less than 10, status cold. Temperature is less than 25, then status is mild, or else status hot. And for the energy classification, if the usage is more than 500, then we would print high usage. Just the similar checks happen, so the highest thresholds come first. Why indentation matters? Indentation continues to be critical in conditional logic. It defines which code belongs to each branch and ensures correct program structure. Because of the spaces, I know that the print it is hot and turn on AC, that function, and this print function, I know it belongs inside this if branch. And then for the else one, it's printing, it is fine. So if temperature is greater than 30, then we take out that order. If it's less, then it's fine. So first, we define the program structure. In Python, white space isn't cosmetic. The indentation level determines which lines of code belong to which logical block. Unlike C++ or Java that use curly braces, Python uses the colon. And consistent spacing to group statements. This is why you're seeing if temperature is greater than 30, then there's a colon. Readability is key. Thus, this enforced structure guarantees that code that runs together looks together. Incorrect indentation leads to an indentation error. A common mistake is forgetting to indent after colon. So this causes an indentation error because Python expects an indented block. For example, if true, colon, but then there's no indent. So it would show an error. So the fix is you put the indent, the 4 spaces. This defines which code belongs inside the if block. When debugging indentation errors, look at the line indicated and also check the line before it, especially if it ends with a colon. So file and line number, when they're having the error, tells you exactly where the crash happened. For example, in this case, it's showing line 2. The caret points to the specific character where Python got confused about the print. And the message expected an indented block. It shows that you forgot spaces after the colon. So always look at the line before the error line. Often the missing indentation relates to the statement immediately preceding it, the one ending in colon. Nested conditionals allow us to place one if statement inside another. This is useful for multi-step decision making. If inside an if. So a nested conditional, it basically is simply an if statement placed inside the indented block of another if statement. So it is ideal for dependent validations where the second check only matters if the first one passes. For example, user or is admin, right? So if it's user, then is it admin? Avoid deep nesting. Too many levels make the code hard to read. Use logical operators and instead when possible. In this example, the correct condition is age greater than or equals 18 because it's showing, right, age equals 20. It's being assigned, the age is being assigned the number 20. And is checking if it has ID. So it's at the moment it's being assigned the value true. So the age is 20 and that user has ID. So if age is greater than or equals 18, first check, then checks if has underscore ID. So since our value is 20, so 20 is greater than or equals 18, so 20 is greater than 18. And then the user also has the ID because it's given true. Then it will print entry allowed. So both conditions must be met in this case to allow the entry. The output shows that both conditions were true, so entry was allowed. So that's what is printed. So this is how the order of the checks happen. The first check, 20 is greater than 18, and then the value of true for the has ID, and then print entry allowed executed. The OR operator only requires one condition to be true. Here, when age is greater than or equals 18 is false, but has ID is true. So the overall result is going to be also true, and the output is partial access. Just a second, these are just some use cases for nesting. So for this nesting, we are having multi-step validation. For example, if its username is valid, if it's true, then we check if the password is strong. If it is true as well, then we create the account, or else we say weak password. Then there is the security checks, right? So if user is logged in, then if it's true, then if user is an admin, then we will show dashboard, or else we show the user profile. Similarly, if for purchase flow, if in stock is greater than 0, then if it's true, then we check the balance. If the balance is greater than or equals to the price, we process the payment, or else we would say we print out insufficient funds. This is for checking energy-related questions. So it's about battery control. So if it's just checking if grid demand is higher than 80, it's just a simple case. Then if the state of the battery is also over 20, then we discharge battery, or else we would say battery too low. So combining the conditions, in this case, we would have to check for the AND. When there is AND, we would have to match both the conditions. Whereas if it's OR, both the conditions can be met, but so can if one condition is met, it will get executed. Not will be if true, then it will go false. So if demand is greater than 70 and state of charge is over 0.2, so both conditions have to be met, and only then the function would be carried out. So something to understand, both for in AND condition, both must be true. The condition passes only if all individual checks are true. Example, true and true would be true, or at least one true. So the condition passes if one individual check is true. It allows flexible criteria. Not is the reverse logic. It inverts the Boolean value, useful for checking if something is missing or incomplete. So the AND operator. So we have to combine conditions where all criteria must be met. In this case, age equals 20. And the has ID is assigned a value true. So if age is greater than or equals 18 and has ID, we print aloud. So for our case, the age is assigned 20 and it has the ID as well. So our print will be in this one, it is just showing the output. It confirms why it happened. Because the first condition was that the age is greater than or equals 18, so it evaluates to true. So 20 is greater than 18, then it meets the condition. Then the second condition is has ID. It's explicitly written true, so it also matches. Hence, our result would be true and true, so it results in true. This is why in one line it's written if age is greater than or equals 18 and has ID, print aloud. So this is the OR operator. So this only requires one condition to be true. Here, the age is assigned the number 16, but the user has an ID because it's written true. So is at least one condition true? Hence it's written if age is greater than or equals 18 or has ID, we print partial access. Since our first condition is not met, since 16 is not greater than or equals 18, but the user does have an ID, we print partial access. The not operator reverses a Boolean value. If something is false, not makes it true, and vice versa. So it's written is ready? No. So it's written false. So if not is ready, print wait. So this runs because not false is true. So the not operator reverses a Boolean value. It is the digital equivalent of flipping a switch. Extremely useful for checking what is missing or invalid early in your code. For example, if not user dot logged in. So this is an example to check what is missing or invalid. Commonly used to disable specific features or logic paths cleanly when using readable English-like syntax. So this is just showing another example. It's given that logged in is false. So not logged in becomes true, and the program prints, please log in. So this is just a Boolean inversion. The not operator flipped the value. Since logged in is false, the expression becomes true. Common syntax errors including missing colons, incorrect indentation, and unmatched quotation mark. These prevent the program from running. So here, as you can see, it's showing the colon is missing, and in the print, like I was just saying, quotation marks is missing, and the indent is not correct under else. So this would prevent it from running. So logical errors are different. The program runs but produces the wrong result. For example, using the wrong comparison operator or incorrect condition order. Here, the program prints pass instead of distinction because Python stops at the first true condition. So here's the bug. If score is equals 85, no, score is assigned the number 85, and it's first checking if score is greater than or equals 60, colon, print, pass. If score is greater than or equals 80, print distinction. Even though the expected output would be distinction, it's just giving pass because Python checks the conditions from top to bottom. So once it found that first condition to be true, it executed that block and skipped all the rest. Since 85 is greater than or equals 60, it's true, and the code printed pass and never checked if the score was high enough for a distinction. This happens because the broader condition was checked before the more specific one, making the correct condition unreachable. The way I was just explaining, that it just went for the first one and it read top to bottom, so it ignored all the rest. The fix is to check the highest or most specific condition first. This ensures the correct branch is executed. So now we have corrected the way of writing it, the logic. So we wrote, if score is greater than or equals 80, we first would print distinction. But if score is less than 80, but it's greater than or equals 60, then it would print pass. Else, if all these two conditions are not met, print fail. So now the output is as expected, distinction. So this is just a quick quiz type of question. So in this temperature classification problem, the current structure is if temperature is greater than 20, else. So for temperature equals 30, the output is comfortable because our temperature is assigned the value 30. So it starts checking if temperature is greater than 35, print too hot. Our temperature is less than 35, so we move to the second condition. If temperature is greater than 20, print comfortable. Since 30 is greater than 20 but less than 35, we print comfortable. The output is confirming this. The first condition fails, the second condition passes, and the program prints comfortable. This slide walks you through the execution step by step, showing how Python evaluates each condition in order. So first it checked for the condition 30 is greater than 35, which was false, so skipped to the next. Then check 2 happens 30 is greater than 20 is true, so result execute block and skip else. We can extend this logic by adding user input or combining multiple conditions such as temperature and humidity. So here we are adding the user input and humidity. So we put the temperature integer, then we call this input and put this temperature. We check the temperature. Then we take the input of humidity. If temperature is greater than 30 and humidity is greater than 80, print it's muggy outside. Else, if temperature is greater than 30 but humidity is not the condition, print it's hot and dry. Just for trying, there's a thermal comfort classification here. So it's given indoor air temperature, T equals 24. So if 24 is, since if 20 is less than or equals to T, which is less than or equals to 26, print comfortable. Since T is 24, it's within 20 and 26. So our system would print comfortable and ignore the rest. The input function allows users to provide data during runtime. Since input returns a string, we convert it to an integer for comparison. Here, input is giving a text. Enter temperature, colon, and in the bracket. So we wrap it in integer. This is why int is having the bracket, and inside it, there's the input. So we convert it to a number, and then we can compare it with the conditions. So here, the program took the user input, converted it, and applied a conditional logic. For example, when the user entered 25, the output became comfortable because it checked the conditions. 25 is greater than 20, hence it printed comfortable. This highlights how conditionals are used to map real-world data into decisions and actions. So how can logic improve? Generally, for example, real systems need to handle invalid inputs, right? Which are like errors. So we use more precise ranges, dead bands, or include humidity for fields like metrics. So when you are dealing with energy or temperature, you can make quick illustrations and check and put more specific deadbands. To summarize, conditionals allow programs to make decisions. Boolean logic drives these decisions, and indentation defines structure. Key concepts include conditions, Booleans, comparison operators, logical operators, and indentation. These are just key concepts to recap about the Booleans. Comparisons produce the Booleans. Every comparison operator, like greater than, less than or equals to, results in a single Boolean value, true or false. This simple binary result is what drives the conditional logic. Then, the logical operators. Complex decisions require combining multiple checks. Use AND when both must be true, or when at least one must be true, and not to invert the logic. Indentation defines blocks. Unlike other languages that use braces, Python relies on white space. A consistent four-space indentation is mandatory to define which code belongs inside an if, else if, or else block. So here you have just tried out different decision modeling skills. So you can now map complex real-world scenarios like energy consumption thresholds into clear binary yes or no pathways that a computer can understand and execute. You've learned to use if, elif, and else blocks effectively. So you have to organize the conditions by priority. Order matters. And using indentation to define clear scope. Remember that if you put, for example, the order incorrectly, a distinction can just become a pass. And then the debugging logic, how you are equipped now to identify both syntax errors, like missing colons, and logical errors, like unreachable code branches, to ensure your programs behave exactly as intended. In the next section, we will build on this by introducing loops, which allows us to repeat actions efficiently. So you are going to try for loops, while loops, and you combine the logic. To practice, try implementing real-world decision logic, such as password checks, pricing systems, or energy control systems, using conditionals.